So the first thing that I just want to point out is that this green blocky here is from your formula sheet. It's the one on the Google Classroom. So it's the one where I've annotated it to sort of block off each of the sections. So if you have had a look at it, you will see that I've blocked off. These are your trig formulas. These are your probability formulas. These are your finance formulas, etc., etc. So that's why it's got a green block around it. That's why it says sequences and series. It's directly from there. It's useful for us to actually know what's what on our formula sheet. Right, however, just as a very quick reminder for ourselves, because obviously it's all very well having a formula sheet, but if we don't know what the formulas are, it's completely useless for us. These formulas that are listed here at the top, so these first two formulas that we are given, these are for your arithmetic. My matrix mocked me today of how I say arithmetic. So I'm going to try and say it better. Arithmetic. Oy vey. And remember, this is your series formula. So it's the sum formula, and this is your sequence formula if you want T of n. So those are your arithmetic formulae. Down at the bottom here in this dark green block that I'm now drawing, these are all for your geometric patterns. Remember, we don't give you anything on your formula sheet that has anything to do with quadratics. So this is your sequence formula, so to find Tn. This is your sum formula, whereas this is for a converging series, hence the sum to infinity. And remember, converging is where our R value is between -1 and 1. So again, it's all very well having a formula sheet, wonderful, but if you don't actually know what the formulas are, it's completely useless to you. So that is what we have here. We are going to use all of them as we go along. And so again, it's useful that you know what's what. But let's have a look at the first question. So let's jump straight into it. So the first question says, the first term of a geometric series is 14 and the sixth term is 448. Now, guys, what I like to do is write this in notation for myself, just because it allows me to see if I need to substitute something into a formula, which variables do I have? So if we look at the first sort of bit here, it says the first term is 14. So this is saying term 1 is equal to, it would help if I could write 14, is equal to 14. And the next bit of information that we have been given is the fact that the sixth term is equal to 448. So term 6 is 448. So I've got two bits of information here. Now, please remember that when it comes to maths, we don't give you useless information. If I'm giving you these two pieces of information, it's because both of them are useful to you. So let's think about why they are useful and which one we can use in which circumstance. Now, remember, if you look at your Tn formulae that we have here, we always have an A variable that we're substituting in. For any of those formulas, there's an A variable, and A is your first term. So this T1 equals 14 actually gives us an A value. So that's why it's useful to me. I automatically know what A is. Term 6 doesn't really give me anything by itself, but maybe it's going to be useful later on. So let's now actually get into the questions to see what we can use where, how certain things are useful, if certain things are useful, and how to go about it. So the first question says, calculate the value of your constant ratio R. Right, so we know it's a geometric series. We know there's going to be an R value. Now, if we think about what we have in this bit of information here, we've got our Tn, and we've got, no, let's try this again. We've got the value of your term, so you've got a Tn, and this 6 over here is the value of n. So you have all of that. You've got Tn, you've got n, and because we know what the first term is, we actually have a as well. So if we go and substitute that term 6 is equal to 448, we're able to find R. So that would be, just to remind you, it is on the formula sheet, Tn is equal to A times R to the power n minus 1. The value of my term is 448. A is 14. R is what we're trying to find. N is 6 because it was the sixth term minus 1. We've got an exponential equation we can now go and solve. So the first thing that I'm going to do is I'm going to divide both sides by 14. Remember, I want to get rid of that coefficient. And if I divide both sides by 14, I get 32 is equal to r to the power, and 6 minus 1 is 5. Now, guys, there's a few different ways you can go and solve this. It's up to you. It's whatever you see. It's whatever you're more comfortable with. You do you. So either you can fifth root both sides in order to get rid of that power of 5. And the fifth root of 32 is 2. So you'd get 2 is equal to r. Alternatively, what you can also say, so you can make your bases the same and you can use prime factors, is that 2 to the power 5 is equal to r to the power 5. Now, usually we try and make the bases the same, but what you need to notice here is that your exponents are the same. If the exponents are the same, then the bases have to be the same. That's just logical. In order for it to be equal, if you've already got the exponents equal, the bases must be equal as well. So again, you get that 2 is equal to r. Either way, you get 2. So it doesn't really matter which one you do, and you must decide which one you would go for, which one makes more sense for you. But either way, we are getting that our constant ratio is r. So we're multiplying by 2. Constant ratio is r. Our constant ratio is 2. And so we are multiplying by 2 to get from one term to the next. So the series is actually diverging. It's getting bigger and bigger and bigger and bigger as we go. Now this is only worth 2 marks. So you would get a mark for the substitution into your formula of your A and your 448 in term 6. And you would also get a mark then for obviously your answer. So only 2 marks, nothing super crazy, but 2 marks nonetheless. So if we look at the second question, 2.1.2, it says determine the number of consecutive terms that must be added to the first 6 terms in order to obtain a sum of 114,674. So let's think about what this is saying. They're saying that we've got the first 6 terms. We've found the sum of all of these. I want to know how many more terms should I be adding in order to get 114,674. That is essentially what the question's asking me. Now, again, there's lots of different ways that you can do this, and it very much depends how your brain works, how you think about this question, what you would choose to do. I think most of our natural sort of inclination would be, okay, well, I've been given a sum. I know that this is an SN value. Why don't I substitute it in to see how many terms I've added in order to get that sum? Because if I know how many terms I've added, and I know that I just want to go, what am I adding to the first 6? That's easy enough to go and work out. So, and I think, like I say, that would be most of our inclination. So this is a geometric pattern, which means our sum formula is A times R to the power n minus 1 over R minus 1. And like I say, you've been given the sum. So 114,674 is equal to, remember we said A was 14. We've worked out what R is. It's 2 to the power n minus 1. Because remember, n is the number of terms that we're trying to find, all over 2 minus 1. So again, my thought process, I have a sum. Let me just work out how many terms I've added to get that sum. I can then decide how many I added on top of the first 6 for my answer. Now, 2 minus 1 in the denominator is 1, so it doesn't really do anything. So we've got 114,674 is equal to 14 times 2 to the power n minus 1. We want to get rid of that 14, so I'm going to divide both sides by 14, giving me 8,191 is equal to 2 to the power n minus 1. Add 1 on both sides because I'm solving my equation. 8,192 is equal to 2 to the power n. And now here, because we're solving for an exponent, we are going to have to use that shift back button on our calculator. So if you type in 8,192, push equals, and then say shift back, you get that 2 to the power 13 is the same thing as 8,192. Your bases are the same, and so what that means is that your n value is equal to 13. So what that's saying, if we go back up to this beautiful diagram I have here, is that in total, we're adding 13 terms. I want to know, the question asked, if we just go back to the question, the number of consecutive terms that must be added to the first 6. So here's my first 6, that's sorted. I want to know how many more terms do I need to add. So I'm figuring out the how many more. If I know in total we're adding 13 and I want to know how many more I'm adding on top of the first 6, well, that's easy. 13 minus 6. So therefore, I'm adding 7 terms to the first 6. So really, really important that you do read your questions carefully, because again, we can't just stop at n equals 13. That's not what the question asked. It didn't say how many terms do I add. It said how many terms do I add? So how many consecutive terms do I add to the first 6 terms? The first 6 are accounted for. I know that I'm adding the first 6. How many more do I need to add in order to get the sum I want? And so, I mean, beautiful as my diagram is, if you need to draw stuff out like that, do it. Like if you need to visualize what's happening in a problem, there is nothing wrong with that. This is how I actually do most of math, because I really struggle to see things if I don't have a picture in front of me. It's not a beautiful picture. It's not amazing. It doesn't like scream art, which is fine. It just helps me visualize what it is that I'm looking for. And if it helps you, draw a picture, do a little scribble, do what you need to do in order to get your answer. So I'm just going to make that a touch smaller so you can screenshot. It is going to start getting a bit too small, so I'm going to do those and then we'll move on to 2.1.3. And guys, remember, if you do have questions, please feel free to unmute yourself or put it in the chat. I got the chat open. I can see you messaging as you go along. So please just let me know if you've got questions as we go along. Okay, so let's see what 2.1.3 says. So 2.1.3, and now guys, also think about the fact that this is all a continuation from 2.1. So all of this information is following from 2.1, which means there is a link with these questions. They're not necessarily all identical, but there's a link. And this is going to be an important point that I'm going to raise now. So 2.1.3 says, if the first term of another series is 448, so again, let's write down what we know. Come on, you silly thing. So first term is 448. And the sixth term is 14. Calculate the sum to infinity of the new series. Now, what I want you to notice is if we scroll back to the information here, we were told initially the first term is 14 and the sixth term is 448. That's now swapped. Now we've been told that the first term is 448 and the sixth term is 14. They've essentially swapped the order or the progression of the sequence. Now, what that means is initially we started at term 1 of 14 and went up to 448. So my sequence was getting bigger and bigger and bigger, and it's geometric. So I was just timesing by 2 each time to get bigger and bigger and bigger. Whereas now I'm starting at 448 and I go down to 14. So as I go along, I'm getting smaller and smaller and smaller. So that means I actually need to be dividing each value consistently or constantly to move down my pattern. Now, technically, because the positions are corresponding and the values are corresponding, we actually already know what R is. Initially, we were timesing by 2. Because we've now swapped everything around, that means my R value is now a division by 2, so a half. Obviously, if you don't see that initially, that's fine. That is not the end of the world. You can go and work out R. I've shown you how to do that. Camilo, I do see your question. I'm just going to lose my train of thought otherwise. So let me just finish this up and then I'll deal with your question. This is our A value because it's term 1. We already know how to do this because we did it in the last question. But we know that if we substitute in this information, we can solve for R. So 14 is equal to, so Tn is equal to A, 448, times R to the power n minus 1, so 6 minus 1. I would divide both sides by the 448, giving me 1 over 32. And if you remember from before, the division yielded 32. So again, it's that inverse, R to the power 5. Again, you've got options if you want to fifth root both sides, if you want to find the prime factors and find that a half to the power 5 is equal to R to the power 5. Either way, you get that R is equal to a half. Okay, so that's what I was saying. If you see the link and you see that it's now the other way around and you can say, okay, cool, R was 2, so now it's a half, that's fine. If you don't need to do all the working out, that's cool. If you do, that's also fine. Whatever your brain is registering, you go with that. So now that we've got our R value, the question asks us to find the sum to infinity, which is A over 1 minus R. And remember, of course, R should be in our range of 1 to negative 1, which it is. So I'm happy. I substitute in A, 448 over 1 minus a half. And so I get that my sum to infinity, that looks like an 8, I'll fix it, is 896. All right, so nothing super complicated. And again, even if you didn't see the link with the R, you can go and work it out. So it's really not the end of the world. Okay, so Melo, I'm assuming you mean 2.1.2, and that is entirely on me. I just didn't say anything. 2.1.2 was 4 marks. So just so that we all know where those marks are coming from. So 4 marks, it would be you substituting in your sum value. Obviously, there's different methods that you could do it, but for this method, it would be substituting in your sum. There would be an element of you getting your bases the same, finding that you had to add 13 terms, and then going back to the original question and actually saying that on top of the first 6, you're adding 7. So that's where your 4 marks would be allocated for that question. In this next question, 2.1.3, it's for 3 marks. So it's getting the correct R value of a half, substituting into your sum to infinity formula, and then getting your answer. Right, so I'm sorry, I should have gone through it, but I hope that's okay now. All right, guys, so take your screenshot here, and then we're going to have a look at the next question, because this is like a new question. It's not a follow-on. Pleasure to mail. Sorry, I didn't even think about doing the mark allocation. I do apologize. Okay, now guys, the next one, my sigma went a little bit weird, so I'm just going to rewrite it so that we actually know what's plotting. Don't know why it went weird. All right, so 2.2 is a sigma question. It's for 5 marks. We'll deal with the mark allocation in a second. Like I said, I don't know why my sigma typed out a bit odd, but this is saying the sum of p equals 0 to k of the sequence a third p plus 6 is equal to 20 and a 6. Okay, so this sigma up here, it basically looks the same. The actual sigma part just went weird, and I could not tell you why, so I'm sorry about that. Right, so we've got that whole fun sigma thing, and it says determine the value of k. So let's establish what we have. Sigma is saying to me, whoopsie daisies, if we add terms 0 to k of the series a third p plus a 6, we get a sum of 20 and a 6. So remember, it's really important that we understand what sigma is saying to us so that we can answer the question. Now remember, K is not the number of terms that I'm adding. K is the last term or up to which term I add. Now that's a really important distinction because as we spoke about on Monday, we don't always start adding at the first term. If I started adding at term 1, then K would be the number of terms that I add. But because in this case, I'm starting at where P is equal to 0, I'm not starting at the first term. So that is something I need to be mindful of, and we'll see how we deal with that in a second. But just bear in mind that if you are not starting at 1, so because P equals 0, because I'm not starting at 1, K doesn't necessarily correspond to the number of terms. It's just the last term that I add. Canisilia, I see your hand. Have you got a question?
Yes, ma'am.
Yes.
Yeah. Ma'am, for K, is K like the actual value of the term, or is it the last amount of terms there is in a sequence? Like if there's 10 things in a sequence, is K gonna equal 10, or is it gonna be equal to the value of 10?
Okay, so really good question. It would be equal to the 10 terms. So it's not the value of the term, it's the 10th term, the 11th term, whatever. So K tells us which term we add up to. So let's say K works out to be 15. It's saying that I'm adding term 0, 1, 2, 3, all the way up to term 15. It's not giving me the value of the term, but it's telling me which term I'm adding up to. Does that answer your question?
Okay, yes, ma'am.
Okay, good. Awesome. Oh, guys, I love hearing your voices. Please can we start asking and answering more questions? I know I'm talking a lot because I want to get through the stuff, but thank you. All right, so that's what we've got, and Kanyasile has summarized or sort of concisely allowed us to explain what that K is. So again, K is not the number of terms I'm adding. It is what is the last term I add up to. So again, if K was 15, we would be adding from, in this case, 0, 1, 2, 3, all the way up to the 15th term. Doesn't mean I'm adding 15 terms, because remember, I'm adding term 0, but it's telling me up to which is my last term that I add. Right, however, sigma, sum, we're going to have to use our sum formula. If we look at our original expression, this is arithmetic. I have such a complex about it now. We know it's arithmetic because it is a linear expression. There's no exponent, so it's not geometric. So it's linear. And what that means is I have to use my linear sum formula. So that's an n over 2, 1. All right, so we need to obviously figure out a few things. We need to know what our first term is, and we need to know what our constant difference is. Now, remember I said to you guys on Monday that when we deal with sigma, the first thing that you should always do is work out the first 3 terms. It just allows us to know what our pattern is that we're working with. In this case, if we then want to use it to find the constant difference, we have it. But if we just find the first 3 terms, we're sorted. So I would want to substitute in P equals 0, P equals 1, P equals 2. So quickly do that for me and tell me what the first 3 terms of this series is. Okay, so I want to know what are the first 3 terms when we sub in P equals 0, P equals 1, P equals 2. Nice, Kirsten. Nice, Daniel. Real nice. Okay, guys, I like what I'm seeing. So we get a 6, a half, 5, 6, and obviously we could keep going if we wanted to. So that now means that we have our value of A, and you can work out your constant difference if you want. I'm going to show you the little shortcut that we did speak about so that you don't actually have to work it out, but we'll get there in a second. So we know what the sum is. This 20 and a 6 is the sum. If you want to write this as an improper fraction, you're more than welcome to. Personally, I prefer improper fractions over mixed numbers. So I probably would write it as 121 over 6. If you don't, that's fine. Okay, it really doesn't matter. It's whatever you're comfortable with. Is equal to n over 2 times a, which we know is a 6, plus n, n minus 1 times our constant difference. Now, you can either go work out your constant difference, so a half minus a 6, 5 over 6 minus a half, that's fine. But remember, in your formula, the coefficient to the variable is the constant difference. So if you were to go and add a third to 1/6, you would get a half. That coefficient that I've highlighted there in yellow is your constant difference. And so you don't actually need to go and work it out. You can just look at the formula that you've been given. If you do go work it out, that's obviously fine. You will get that you are adding a third each time in order to get this the consecutive term or the next term. So whichever one you want, it really doesn't matter, but you can just look at the formula. Alrighty, so obviously we're trying to solve for n here. So we've got some fractions, which is not an ideal situation to be in, but we can live with it. I would always prefer to get rid of the fraction in front of the bracket first. So I'm going to times both sides by 2 in order to get rid of it. And that leaves me with 121 over 3 is equal to n times 2 times a 6 is a third, plus I'm going to distribute this third in, a third n minus a third. What you see is that a third minus a third actually cancels out. And so on the right-hand side, we've got n times a third n, which is a third n squared. Now, guys, what you should also see here is that your denominators are both 3. So yes, you can times by 3 on both sides and cancel them out, but because the denominators are identical, you can just essentially drop them. They're already the same. They're already equal to each other. It's now the numerators that have to be equal. So we're actually working with 121 is equal to n squared. If you want to solve this quadratically and do the difference of 2 squares, that's fine. Alternatively, you square root both sides and you get that n is equal to plus or minus 11. Now remember, n is the number of terms that we're adding. So, excuse me, we can only add a positive number of terms. So in this case, we can eliminate the one solution and n is equal to 11. Now I want us to just go back to what this actually means. This is saying from, oh, golly, Miss Molly, from p equals 0 to whatever k is, we're adding 11 terms. Now that's an important distinction. It's been a Wednesday. It's an important distinction to make because remember we spoke about this when we did sigma. If you do not start at 1, you need to be very careful of how many terms you're actually adding. And this is where that formula is of top minus bottom plus 1 is really useful for us. If I'm starting from 0, that's already the term 1 that I'm adding. That's already 1 of the 11. Then p equals 1, p equals 2, p equals 3, p equals 4, p equals 5, p equals 6, 7, 8, 9, 10. Right? So up to 11 terms, I'm going up to p equals 10. And that's because my first term that I'm adding is 0. So because I'm not starting at p equals 1, I need to be careful. And this formula here is going to help me figure all of that out. So remember, this gives me the number of terms that I'm adding. So we could substitute in 11 here is equal to the top number, which is k, minus the bottom number 0 plus 1. Obviously, k minus 0 plus 1 is then just k plus 1. Subtract 1 on both sides. You get that k is equal to 10. So again, please remember that because we did not start at p equals 1, it does mean that we need to be very, very careful about solving for k. So I'm going to just show you again on my fingers. P equals 0 is the first term that I add of the 11. Then it's P equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are 11 terms all the way up to P equals 10. And that's because P equals 0 is the first of the 11 that I add. So the little formula that I've put in the rectangle there is really useful to remember, particularly when we're not starting at 1. So we have to bear in mind that, yes, I'm adding 11 terms, but k, the value at the top, is 10. Because as Kanisile said earlier, k is the last value that I stop at in terms of the terms that I'm adding. It's not a value of a term or anything like that. We are going to stop at k equals 0. K equals 0 at k equals 10. So we started at p equals 0 and we're going to go up to 10. So we need to be very, very careful of that, like I said, especially when it doesn't start at 1. So sorry, Great Tolls. So this was 5 marks, so it was a decent chunk of your marks. So you would get for substituting your values into your sum formula. You would get for having your A value, because that was something that you would need to work out. And Kirsten, I do see your hand, I'll get to you in a second. You'll get a mark for getting your equation simplified. You'll get a mark for n equals 11, and then you get a final mark for k equals 10. So understanding that you started at 0, and so k equals 10. Kirsten?
Hi, ma'am. I have a question based on when we use the top minus bottom plus 1 formula. Is it towards the end of solving when you're supposed to, like for example, when they say determine the value of k and you're supposed to get it alone, will you use it in that circumstance or?
Yeah. So remember, k in this case is the top value. So k is the top. So once I've figured out, because I've got so much going on here, this formula over here is for the number of terms that I'm adding. So n is the number of terms. K is then where I stop in my sequence. I stop at term 7, I stop at term whatever. But I don't always have to start at term 1. So I would only use this formula, the top minus bottom plus 1, if this bottom number is not n equals 1, p equals 1, whatever equals 1. If that is not equals to 1, then I would use this formula. If it was equal to 1, then we've got no problem, because then it's 1, 2, 3, it matches up perfectly, and then whatever you get as n, that is your top number. But in this case, because of that 0 throwing us off, that is when I would use this formula. Does that answer your question?
Yes, ma'am.
Okay, awesome. Right, guys, so take your screenshots here, and then I think we move on to question 3, which if I remember correctly is a quadratic. Quadratics is one where they do also like to introduce complex questions. So reading the questions here is really, really important for us. Alrighty. So if we have a look at question 3, and again, break down what the question is saying to you before you actually get into the individual sub-questions. It is given that the general term of a quadratic number pattern is t of n is equal to n squared, plus bn plus 9. And the first term of the first difference is 7. Okay, so there's a fair amount that we need to just unravel there. And if we read it carefully, we should be okay. So the first thing I'm going to delve into was the initial bit of information about the formula. So we are told that this is our formula. Now remember, this comes from Tn is equal to an squared plus Bn plus C. So C in this case is 9, and in this case, our coefficient to n squared is 1, so A is 1. The only thing I obviously don't have is B, and if you look at the first question, it says show that B is equal to 4. We'll get there in a second. That's the first bit. I know what A is, I know what C is, I don't know what B is. That's fine, we'll get there. The next thing that I've been told is this fun situation that we have going on here. The fact that the first term of the first difference is 7. Now what that means is the following. We would have term 1 of our quadratic, term 2, term 3, etc., etc., etc. Remember that when we find the difference between term 1 and term 2, these are our first differences. So the difference between term 2 and term 1 is a positive 7. So if I add 7 to term 1, I get term 2. We don't yet know what the next difference will be, but that bit of information is saying to me that if I say term 2 minus term 1, I get 7. That's also really important to answer the first question. Before we get there, remember quadratic patterns, we don't give you any of the formulas or any of those equations on the formula sheet. You have to know the following. So just to summarize the stuff that you do need to know, it is the 3 formulas. So the first formula allows us to find A. 2A is equal to our second difference. Now in this case, we already know what A is. Remember, we know that A is 1. So we don't need to stress about that formula, but just remember it. The second formula that we have to know is 3A plus B is equal to term 2 minus term 1, essentially the first difference. And if you have a look here, we've been given that. That was my 7. And the third equation is A plus B plus C is equal to term 1 of my quadratic pattern. Again, I don't need that because I know what C is. The only formula here that I'm actually concerned about using is the second one over here, because that allows me to calculate B, and the question is saying, show that B is equal to 4. Right, so what we're going to do is we're going to use our formula and we're going to substitute in. So 3A plus B is equal to the first term of the first differences, so 7. And remember, A is equal to 1. So we've got 3 times 1 plus B is equal to 7. And so B is equal to 4. Now, go-tells, I just want to take a little moment here. In questions like this, where it says show that, so we often do it in functions for quadratics, where we'll say show that A is equal to this, B is equal to this, C is equal to this. You may not use the value that I've given you in your working out. The only time that I should see B equals 4 is in your final answer. At no point should you be using the values that we give you in your working out. If you just go and substitute the values in and prove that it's true, you are not showing me, or you're not proving me that the value is correct. All you're doing is you are assuming it's correct and showing me that things work out. So you may not use the value or the values that I give you. That's really important. If you do, you will get 0. So show that questions, prove that something is true, whatever. You may not just make an assumption that all of it is true and then use those values in your working out. You actually need to go and show it. So if you have a look here, at no point did I ever use B equals 4. The only time you see it is in my final simplified answer. That's fine, because now you've actually showed that it equals 4. But you have used the other given information in order to get there. You haven't just substituted in what you knew. So that is really, really important. Please do not just use the values. You actually need to go and show. All right, so that's my spiel done. 2 marks. So not hugely heavy on the marks again. You would get a mark for substituting all your values into the correct formula. And you would get a mark for your sort of simplification of it all in order to get to the B equals 4. We will not give you a mark for B equals 4 because we've given you that information, but we will give you a mark for accurately simplifying to get to where you need to be. So only 2 marks. Oh, nothing tricky there. In fairness, we might even give you a mark for saying, or for understanding that A is 1 from the original formula. In this case, I'd probably allocate a mark there. So 3.2 now says determine the value of the 60th term of the number pattern. Now, guys, which variable would I now substitute with 60? Am I going to substitute Tn or am I going to substitute n with 60? As here, Flumelo, very nice. So 60th, can you see there? Nice is a position. Kirsten, nice. This is a position. And so it means that we have been given that n is equal to 60. Now remember, you've been given the formula. Tn is equal to n squared. And guys, this is also really important. If you couldn't prove that b equals 4, in the next question, assume that it is. Because the question said show that b equals 4. So I'm sort of telling you it is equal 4, just prove that I'm right. So if you made a mess up in the first question, sorry, just then use that value in the second one. So we've got plus 4n plus 9. And we now want to term 60. So we're just going to substitute 60 in place of n. And we're going to solve for its value. So I'll give you a second or two. What is the value of the 60th term here? Nice, grade 12s. Amazing stuff. 3,849. Excellent. Well done. Right, so it's only 2 marks. So you're going to get a mark for substituting n equals 60. So you get a mark for knowing that n was 60 and a mark for your answer. Okay, good. I'll make this a bit smaller in a second. Let's do 3.3 and then I'll make it smaller for us. So 3.3 says, determine the general term for the, my typing wasn't great here, so bear with me. Determine the general term for the sequence of the first differences of the quadratic number pattern. Write your answer in the form TP is equal to MP plus Q. Okay, so we're gonna, again, unpack a few things. Firstly, this TP equals MP plus Q. All this is saying is use your TN formula for the arithmetic. The only thing that we have to remember is that we must simplify in this case, because simplify, they want essentially an n term and then a constant term. So we will have to simplify. This is also why I said to you when we did arithmetic number patterns and sequences and series, this is why I always say just simplify it. At least if it's simplified, you can't really go wrong with things like this. Just simplify it. Okay, so let's unpack the first part of the question. Determine the general term for the sequence of the first differences of your quadratic number pattern. Okay, so if we unpack this a little more, we know that we will have term 1, and let's actually do it like this. This is my quadratic. We've got term 1, term 2, term 3, etc., etc., etc. I'm not going to go more than term 4. You get the vibe. We also know that the first differences of a quadratic pattern, I'm so sorry, the first differences of a quadratic number pattern form an arithmetic pattern, so form a linear pattern. So here, my first differences form that arithmetic pattern. Now we already know that the first difference between term 1 and term 2 is 7. we don't know the rest of them. We do need to figure out what the rest of them are because we need to know, we know what our A value is, but we need to know what our constant difference is. So in order for us to do that, we will need to find the first 3 minimum terms of the quadratic pattern. Now, we already know what the quadratic sequence is. Tn is equal to n squared plus 4n plus 9. And so we can substitute n equals 1, n equals 2, n equals 3 to get these first 3 terms. So if you go and do that, you get that the first 3 terms are 14, 21, and 30. So I'm just going to take this away and we're going to write those in. Sorry, guys. We don't really need to inform. 14, 21, 30. So you can clearly see that 14 plus 7 is 21. If we now move on to our next difference, 21 plus 9 is 30. And so our constant difference is an addition of 2. So this is my constant difference of the arithmetic pattern. If you were still considering the quadratic, that would be your second difference. But right now, actually what I care about is my linear or my arithmetic pattern. Okay, so here we are. Here's our arithmetic pattern. We know what our constant difference is. We also know the formula that we have to use in order to find the general term. So what I want you guys to do for me is I want you to tell me what the general term is. What is the Tn formula for my linear number pattern? So the 7, 9, 11, and it would keep going like that. I'll give you like 2 or 3 minutes and then we'll have a look. And remember, grade 12s, you can double check yourself. So if you're not 100% sure, once you've got your pattern, substitute in 1, 2, and make sure you do actually get the pattern that we have here. Flumeno?
Hello, ma'am. Can you please
Hi.
explain again why why we're simplifying to the arithmetic sequence?
Okay, cool. So if you didn't hear, guys, why are we simplifying or why are we going to the arithmetic sequence? I've got such a complex about how I say it now. So it says determine the general term for the sequence of first differences. Now the sequence of first differences is arithmetic. So that is why we have to go to the arithmetic formula, because if we look at the first differences of a quadratic, they always form a linear pattern. And so once I know what those first differences are, the 7, 9, 11, 13, etc., etc., I can go and work out what my formula is. So because of the way the question was asked, the general term for the sequence of the first differences of the quadratic, I know that I'm working with an arithmetic linear number pattern. Yeah, so Flumelo, I hope that helps. If not, obviously just let me know and I can try and explain it a bit differently.
Thank you, ma'am.
Right, guys, nice. I like what I'm seeing. I'm just going to do the substitution so that we can all see. So A, maybe I need a pen here. Remember, it's A plus n minus 1 times D. So Tn is equal to A. 7 is my A term. 7 plus n minus 1 times my constant difference 2. I need to distribute. And remember, they're asking for my variable to be P. So in place of n, I'm now going to have T of P is equal to 7 plus 2P minus 2. 7 and negative 2 are like terms. So we subtract 2 from 7 and we get positive 5. So that's where I'm getting that formula from. Again, double check yourself if you're not too sure. You obviously don't have to write out the check. You can just do your check on your calculator. But if you do a check for yourself, substitute in P equals 1. So term 1 is equal to 2 times 1 plus 5. That's equal to 7. That is my first term. If we do term 2 is equal to 2 times 2 plus 5. Obviously, my block is too small. That's 9. That is my second term. So I know that my formula is correct just through a quick check substitution. There's a lot going on here. I'm just going to ignore my situation. Alrighty, guys. So take your screenshots. We do have 5 minutes, so I'm going to do the last question. Obviously, if you need to go at 7 o'clock, I do understand. So please don't feel you have to stay longer. If I run over time by a minute or two, it won't be longer than a minute or two. But if you do leave, please do remember there is a quiz on the Google Classroom. Please make sure you do it. There should be no issues, hopefully. But if there is an issue, obviously just let us know. Just quickly in terms of the mark allocation here, remember it's for 3 marks. So your first mark will be actually getting your terms of your linear sequence, of your arithmetic sequence. Once you have that, substituting into your formula with your constant difference of 2, and then getting the correct general term, the 2p plus 5. Alrighty. So if we have a look at this last question here, 3.4, and I want to do this because this is one we'd love to ask, so it's good to know how to do it. Which 2 consecutive terms in the quadratic number pattern will have a first difference of 157? So again, we're going to break down what we've been given so that we actually know what's going on. So remember, you have term 1, term 2, term 3, term 4, blah, blah, blah. Between these differences, or between those terms, we have a difference. So this was 7, the next one was 9, the next one was 11. This is because we now know what the linear pattern was, etc., etc., etc. The question is asking me between which term, so let's call it Tn, and the next term, which would be Tn plus 1, because it's the one after, will there be a difference of 157? So the question is asking me, if we just go back to the actual question here, which 2 consecutive terms? So I want to know what terms in my quadratic sequence, when I say the difference between the 2, I get 157. Now again, guys, draw these things out, sketch it for yourselves, do a little whatever you need to do in order to understand what's going on. Now, what I want you to take note of is the fact that the difference between term 2 and term 1 of your quadratic gives you term 1 of your linear. Between term 3 and term 2 gives you term 2. Between term 4 and term 3 gives you term 3. So you can always match it up if you understand where the differences are coming from. What we now need to realize is that this 157 is a term in the arithmetic series, arithmetic, because we know our first differences is an arithmetic sequence. So because we know that, and because we've just worked out that TP is equal to 2P plus 5, I can now go and substitute it in there and I can solve for my unknown. All right, so if I now go and do that, 157 is equal to 2p plus 5. So I'm going to subtract 5 on both sides, giving me 152 is equal to 2p, which means that p is equal to 76. And so what that's telling me is that the 76th term of my linear pattern is 156. Now go back to the pattern we saw. Between term 2 and term 1, we get the first term. Term 3 and term 2, we get the second term. Term 4 and term 3, we get the third term. So these 2 terms of my quadratic sequence here are 76 and 77. Those are the 2 consecutive terms where I will find a first difference of 157. Now, this is not a hard question by any stretch of the imagination in terms of the method. If you look at that method, that is very straightforward. What is hard here is understanding what the question is asking you. It's understanding that your first differences form a linear pattern. Now, obviously, we scaffolded this in that the question before this, you found the linear pattern formula. But sometimes we don't even do that. We just ask this question like this, and then you'd have to go and find the quadratic terms, the formula, substitute, etc., etc. But once you know, okay, cool, first differences form a linear pattern, it's easy enough to answer. All right, so here again, 3 marks. So your mark allocation, your mark allocation here will be for substituting 157 in place of TM, so understanding that a term value that I've given you, solving for P equals 76, and then giving me that the 2 consecutive terms are 76 and 77. So if you said 77 minus 76, you will get 157 as your first difference. So that's where your 3 marks come from in this question. Now, guys, if I'm not mistaken, this was about 20 something marks. I can't remember exactly what it was now. 24 marks, right? That's 24 marks that you can guarantee. That's 16% that you can guarantee in finals. Right, I'm fully aware of the fact that it is 7 o'clock. I will leave this up here in case you want screenshots.